This is lesson 3, titled Squares and Square Roots of Non-Perfect Squares. Given the area of a triangle, A equals 1/2 base times height, find the area of triangle A, B, and C. Well, triangle A, area equals 1/2 base times height. So we have 1, 2, 3 by 1, 2, 3. So it equals 1/2 3 times 3, which equals 4.5 units squared. Oops, already. Okay. Our next is angle B. So for angle B, we have 1/2 area equals base times height. So we have our base is 1. Our height is 2. So our area is 1 unit squared. Our third one, our triangle C, is 1, 2, 3, 4, 5, 1, 2, 3, 4. So 4 by 5. So I'll put that down here. So area equals 1/2 base times height, which is 1/2 4 times 5, which is 10 units squared. Okay. So next we have what is the area of the square? Well, because we can't find it normally, what we'd have to do is draw a square around the square that's there.
Mackenzie Sullivan, please report to F27. Mackenzie Sullivan
Okay.
to F27.
And
thank you.
What we would need to do is I can't believe I'm making so many mistakes here. Draw our square. And now we will take our area of each of our triangles and take, this will be square A. This will be square B. And what we're going to need to do is take the area of square B and then subtract out the area of our triangles to get the area of our square A. Excuse me. So taking the area of square B, where area of the square is s squared, is area equals s squared, which is 5 squared, or 25 units squared. Then the area of our triangle, which equals 1/2 base times height. And if you notice, they are all the same. They are 1, 2 by 1, 2, 3. So we have 1/2, 2 by 3. So they are all the same. I'm going to put that here. So that makes this 3 units squared. And because they are all the same, we have 4 of them. So we can multiply 4 times 3 to get 12 units squared. So now to find this area of the square of A, it would be the area of square B minus the area of the 4 triangles. So here we have 25 minus 12, which equals 13 units squared. Okay? So now, the next thing, it says, what is the measure of the side length? Okay? Well, the side length would be the square root of the area. So for our side length here, would be the area of the 13 units squared. So in this case, it would be the square root of 13 units. Okay? So next, it says, is the area a perfect square? The answer is no, it's not. Is there an integer you can square to get this area? No. Okay. But it says, which 2 perfect squares is the area closest to? Well, the 2 perfect squares that the area is closest to would be square root of 13 is between the square root of 9, which equals 3, and the square root of 16, which is equal to 4. Okay. So next, it says place the square root of these perfect squares on the number line. Well, to do this, on the number line, I would have to do 1, 2, 3, 4, 5, 6, 7. And it would be about here on the number line, just about past half. And actually that's half, so it would probably be right about here. Okay, so that would be about right there. Okay. So D says, determine which integer the side length of the square is closest to. Okay. So it says determine which one. So the side length is closest to 4 units. Okay. So now for example number 3, we have. Again, we have the square, so we're going to draw our square around it. Okay. Our area for square B is 2 by 2, so that would be 2 squared, which would equal 4 units squared. Let me erase, excuse me, the one set of equal signs. Okay. And then our triangles would be one half base times height, which would equal 1/2 1 times 1, which would equal 0.5 unit squared. Well, when we multiply that by 4 times 0.5, we get 2 units squared. So now to find the area of square A, we have 4 units minus 2, which would equal 2 units squared. So now our side length in square notation would be the square root of 2 units squared, which would equal square root of 2 units. And then it says side length to the nearest integer. Okay, well, I would say the square root of 2 is between square root of 1, which equals 1, and the square root of 4, which equals 2. And the square root of 2 closest to 1 unit. Okay. So next, we have very big square. If we were to draw our square, went too far. There we go. All right, so the area of our square B is 10 units. 10 squared is 100 units squared. triangle. One half base times height, which is 1/2. 4 times 6. Which equals 12 units. Squared. So now to find square A. Oh, we got to multiply that by 4, sorry. So we got to multiply that by 4. So 4 times 12, 48 units squared. We have square A. And we want the area. So for that, we've got 100 minus 48, which would equal 52 units squared. Okay. Now we have a side length in square root notation. So we have the square root, 52 units squared, excuse me, and then the square root of 52 units. The side length to the nearest integer, we would have the square root of 52 is between the square root of 49, which equals 7, and the square root of 64, which equals 8. So the side length is closest to 7 units. Now our last problem here, we've got, let me see if I can draw this right this time. Oh, looky, I did. Okay, so we've got square B, square A, okay. So we have square B, and its area, which is, excuse me, 5 units long, which equals 25 units squared. We have our triangle, which is 1/2 base times height, which is 1/2, and that is 1 times 4. And as you can see here, so we have 2 units squared. Excuse me. So then multiplying that by 4, so we have 4 times the 2, which equals 8 units squared. Okay. So now to find the area of square A, we have the 25 minus 8 equals 17, not the square root of yet. units squared. So now to write the side length in square root notation, we have the square root of 17 units squared, which is the same as 17 units. Our next is the integer, so the square root of 17 is between the square root of 16, which is 4, and square root of 25, which equals 5, and it's closest to 4 units. This ends our lesson.